An Introduction to Radicals. Intro to Radical Expressions. First, let's discuss some vocabulary. Notice what's written on the paper. First, we have what's called the radical. It looks like a division symbol, but it's not quite. The number or the letter N in that place is known as the index. The part under the radical is referred to the radicand. Finding a root means to find the number that times itself so many times that gives you that result. So here's how you simplify or find the root of a radical. First, you make a factor tree. Second, you rewrite all the factors under the radical. Third, you pull out sets according to the index. And then last, you check. Example 1, simplify. For A, we have the square root of 324. So here's a reminder of the 4 steps we follow. First, we make a factor tree. Now 324 is a pretty big number, but notice it's even, so let's start with a 2. 2 and 162 can go into 324. 2 is prime, so we're done factoring that branch, but 162 can still factor down. Notice 162 is even. Let's take out another 2. If I take out a 2, that leaves me with 81. 2 is prime, but not 81. So let's factor again into 9 and 9. Now 9 is not prime. We know 9 factors into 3 and 3, which are both prime. But we have that other 9 that also factors into a 3 and a 3, which again are prime values. So we've done step 1. We've done the factor tree of the value 324. Step 2 says to write the factors under the radical. You do want to take the time to group them up. So put the 2's with other 2's and the 3's with other 3's. That's all for step 2. Now step 3 says pull out sets according to the index, that little number that kind of lives in that crack. Do you see a number there? What number is understood to be there? Well, if you do not see a number there, we read it as a square root, which means there is an imaginary 2. So step 3 says pull out sets according to the index, and it means we're going to have sets or pairs of values. So let's see if we have a pair of anything under the radical. Notice we have a pair of 2's, so they get to come out of the radical. We have a pair of 3's. They can come out of the radical. We have another pair of 3's. They can come out of the radical. Notice there's nothing left under the radical, but on the outside we pulled out a 3, and a 2. So now we multiply these values. 3 times 3 times 2 is 18. So 18 is the square root of 324. The last step is to check. And to check would mean multiply 18 times 18, and you should get the number 324. B. This time we have the cube root of 216. We're still going to follow our 4 steps. Step 1, do a factor tree. Notice 216 is an even number, so let's start with the 2 and 108. 2 is prime, but 108 is not. Notice 108 is an even number. Let's pull out another 2, and that leaves us with 54. 2 is prime, but 54 is not. Let's take out a 6 and a 9. Now notice 6 is not prime. 6 is made up of 2 and 3, but those are prime values. And now we go back and look at the 9. 9 is really made up of 3 and 3, which are both prime. So we have now officially factored the value 216. Step 2 says write these factors under the radical. Take the time to group them up. Put the 2's with other 2's and 3's with other 3's. Step 3 says to pull out sets according to the index. Look at the index. What is the index in this case? The index is a 3, which means a set must have 3 of the same values. So let's see what sets we have. We have a set of 2's and a set of 3's. Notice everything came out of the radical, and all we have left is 3 times 2, which we know is 6. And so to check, what you would do is you would multiply 6 times itself 3 times, and you should get 216. For C, we had the square root of 196. This is your try it problem. Okay, let's see how you did. You should have done a factor tree, written the factors all under the radical, pulled out your sets, and you should have been left with 7 times 2, which you know to be 14. D, we have the square root of 16y to the 6th. So first we're going to do our factor tree. We have 16, and we know 16 is made up of 2 times 8. 2 is prime, but 8 is made up of 2 times 4. Again, 2 is prime, 4 is not, but we know 4 is made up of 2 times 2. So what you notice is in this problem we have already factored the 16, and we are going to write those under the radical. But what makes this problem different is the fact that we now have variables under the radical. So looking at y to the 6th, well, what does that really mean? Well, y to the 6th means y times itself that many times. In other words, it means y times y times y times y times y times y. Once it's expanded, you can now write that under the radical. Now we look to the index, and we have an imaginary 2, which means we must find pairs of values. Notice we have a pair of 2's, another pair of 2's, y, a pair of y's, and another pair of y's. Notice there is nothing left under the radical, and what we're left with is y times y times y times 2 times 2. Now we are used to seeing the values in front, so what is 2 times 2? And what's another way to write y times y times y? So in this case, your final simplified answer will be 4y cubed. For E, we have the square root of 18. For 18, we would do a factor tree of 2 and 9, but we know 9 is made up of 3 times 3. So we write the factors under the radical, and we look to the index. Because we do not see a value in the index, it is understood to be an imaginary 2, and so we look for pairs. Notice you do have a pair of 3's, which get to come out of the radical, but in this case the 2 does not have a complete set, so the 2 must remain under the radical. In this problem, your final answer will be 3 times the square root of 2. For F, we have the cube root of 20. So we do the factor tree for 20, and we come up with 2 and 10. 2 is prime, but 10 we know is made up of 2 and 5. 2 is prime, so is 5. So we write our factors under the radical, and now we look at the index. The index in this case says we need to have how many pieces in a set. Well, notice we have no sets. We have to have 3 of the same values. So since nothing can come out, that means this radical cannot be simplified, and so our simplified version would remain a cube root of 20. This is your try it problem. The fourth root of 162. Let's see how you did. You should have written all the factors under the radical. Notice the index is a 4, which means you need 4 of the same values for a set to be complete, and you do have a set, which means your final answer should be 3 times the fourth root of 2. Example 2, simplify. For a, we have the square root of 72m to the 5th. 72, we do the factor tree, 2 and 36. 36 is made up of 2 and 18. 18 is made up of 2 and 9. And 9 is made up of 3 and 3. Again, you could have used any two values for the factor tree of 72. No matter what you started with, everyone should come up with the same factors. So we rewrite these factors under the radical. Now we focus on the variable. M to the 5th really means what? Well, it means m times m times m times m times m. It means m times itself that many times. Now that all the factors are written under the radical, let's look to our index. Because we do not see a specific value, it's understood to be an imaginary 2. So take a moment to find all your sets. Notice there's a set of 2's, a set of 3's, m, and another m. So we were able to pull out some values outside the radicals, but we still have a few values left under the radical. So we need to clean this up a bit. Outside the radical, we have the values 3 times 2, and we have m times m. So we rewrite this as 6m squared, and then under the radical, 2 times m remains a square root of 2m. And that would be your final answer. For b, we have the cube root of 24, a to the 6th, b to the 4th. So again, go ahead and take the time to do the factor tree for 24. For 24, you should have come up with these values or factors for 24. Now that you have these factors, write them under the radical. For a to the 6th, we will expand that. And then for b to the 4th, we will expand that. Now that everything is listed under the radical, now let's turn our attention to the index. The index says we need 3 of the same value for the set to come out. Take a moment now to find your sets. You should have found a set of 2's, a set of a's, another set of a's, and a set of b's. And so on the outside, you have b times a times a times 2, and under the radical, you still have a 3 and a b. So for your final answer, you should have found 2a squared b times the cube root of 3b.